So this is a build video. I'm going to be using the Lumenier Lux HD H7. I already put it on this copter. I'm going to add it or replace the flight controller on this one. I like this a lot. It has a lot of awesome features. The features scream INAV because there's so many inputs, a lot of COM ports. You're going to need all that stuff for INAV if you're going to put a lot of peripherals on it. This has more COM ports than I really needed on this. I went COM port crazy because I had an Airbot flight controller before. It was the OmniNext, and the one before that was the F7V2. And apparently, let's say it has 6 or 7 COM ports. Not every COM port has both transmit and receive. Some of them were just receive, some of them were just transmit. And a lot of you may know that if you have a device that you're connected to and you're using the TX pin, you can't use the receive pin for something different. So that you can run out of UARTs real fast when it comes to something with those two limitations there. This one does not have that limitation. They're both, all of the COM ports in there are full transmit, full receive, although if you combine, if you have a combination protocol, then you're only going to be able to use, I think it's just transmit for certain functions, so the receive has to just not be used. So my first concern with the board is it doesn't have a native listing in Betaflight or INAV. You're not going to find the Lumenier Lux H7 as a copter as a firmware to pick from, and that is according to GETFPV. They want you to use the Matex H7, and that's clearly listed on their site. And I was a little worried about that. So when I did my first build, I ended up using INAV. Various versions of INAV didn't work for me. The earlier versions did not support Ghost. The newest versions were ill-behaved. I don't know whether it's still work in progress or not. I tried Rev 6, Build 6, it was release candidate 3, and the configurator was buggy. The firmware didn't work right with this board yet. Back to Betaflight though. Oh, by the way, I'm sorry, I'm going to stay on this one here. The best INAV firmware that I've found to date, as of the date of this video, is version 5. Now, version 4, version 5, and version 6 each requires their own configurator. So you can't use version 5 to do work in version 4 and vice versa. So what I did was I got version 5 on here. Version 5 configurator is installed. But what's interesting with INAV is it does not replace the previous configurators entirely. If you just go with default install, you can leave version 4, version 5, and when you put version 6 on, you can just select them whichever version you want to use. What I did was create icons on my desktop, and I renamed them for which version they called up, and that helps a lot when I was flip-flopping back and forth. So for right now, forget about version 6 with this flight controller. Version 5 is the one you want to use to make this work. My other concern with this was that on the firmware that came with this that I couldn't use, once I made a few configuration changes, there were no I2C errors. But on version 5, I was left with 50 I2C errors. However, everything works on the board. I'm able to switch to use the VTX power switch. All the other things that you're supposed to be able to use with this board, they all, at least as far as I went, they all work. The baro, you have to manually configure the barometer. It doesn't pick it up automatically, so you have to do that in the CLI. And there's a couple other special tweaks, so you want to take your time, be careful, make sure that you set this board up right in INAV. So that's it for INAV. And this build right here, I'm going to show you how it fits in there. By the way, I was able to reconfigure my stack because I had the video transmitter in the back. I was able to stack it on top. So this is my 4-in-1, this is the flight controller, and this is my VTX. I love this USB-C because you know how USB connectors work. You go to put it in, it don't go in. You turn it over, it still don't go in. You turn it back and it goes in. This one here, either way, it goes in. I'm very happy with it. It flies pretty good. I haven't spent a lot of time with it, making sure that everything was perfect, but I'm satisfied with it as of this moment. I wanted to talk about this camera real quick before I put this one to bed. This is the Foxeer T-Rex, and I was a little put off with the way I wanted to use this camera on this build. I want to use this for a camera platform. It ain't going to be perfect. It'll be good enough, but this lens is so wide angle, it's ridiculous. If I'm sitting on a long straightaway, if it's sitting this way and my drone is looking at it, it's this big curve. I can see everything. I can see almost full left and full right with this. So if you want to go through gates and stuff, this is probably the camera. But if you're looking for, you know, a tighter view, that ain't going to be the camera for you. So you have to forgive me as far as video quality and audio quality. This isn't the best camera that that you can use for this. And if I bring anything any closer than this, it's going to go out of focus. So I'm going to have to do everything at a distance so it's not blurry. But this is the flight controller. And a brand new flight controller, unless you're a big hairy, you can have a lot of fun messing with it. You can put on different versions of software and you can see what works, what don't work. I had INAV on it and off to see if the latest release candidate worked with it, if it worked any better without messing with my final build, the one that I showed you before. I put the latest, greatest Betaflight on there, and it was very happy with it. I have no I2C errors. Once I turned off the, as you can see, there's nothing hooked up to it. So once I turned off some of the common devices that you would attach to a flight controller, my I2C errors went to 0. So Betaflight 4.4 is on here now, 4.4.0, and it's looking real good. So what I did after that was I set on, you know, what my final goal is going to be before I wire it up, so that the flight controller is almost all the way programmed. I set up smart audio and turned on the motor outputs and everything else that you would have to do before you can use the board for real. There has been some concerns about this board, about this. Hey, is that going to fly out when I crash? If it's a bad crash, maybe, but there's a pretty good amount of friction there. But what I'm going to do is take a little piece of electrical tape and I'm going to cover this whole thing and extend a little piece onto the card, maybe halfway out, and that will give a little extra protection, and I seriously doubt that's going anywhere. Something to point out with the board, though, that a lot of people, their reviews didn't point out, at least I don't think they did, was if you're not good at soldering, you're going to have trouble with this, because this is a very tiny pointy tip, and you can see it compared to the pads. These pads are very small, and there's no holes to solder to except for over here. So you're going to be soldering to pads. I do like to use the connectors on here. They fit pretty tight, and the connectors are great so that you can work on your drone or copter, whatever you want to call it. You can just pull the plugs out, and if anything is hardwired onto there, you just leave a little extra length, and then you can just lift it off and kind of move it out of your way and do what you have to do underneath, put it back in, plug everything in. I plugged right into the 4-in-1 ESC when I built the one that I was showing you before. There is a wire kit that you can get on Race Day Quads. It's fantastic. It has wire leads. One end is going to be 1.25 millimeter spacing, pico blade. I forget what the other term is used for those kind of plugs, but they're common for cameras and VTXs. And then on the other end is JSTSH, which is what these jacks are. This one I think is pico blade, because that's for the camera, but these guys are for all your motor output. So if you buy that kit, it comes with a bunch of plugs, a bunch of double-ended cables already crimped up, and there's things I've crimped them myself, but it's tedious, and you're like questioning yourself, like, is that crimp good enough? Am I going to have an intermittent problem? Buy the cables, all different colors, different lengths, and you just push them in the locations you want on the plug, on the other end, and it's perfect because if you need the pico blade end and the other end has to be soldered, you just cut off the JST, and vice versa. Solder the other end to your board, or put the plug on the other end and plug it into your device that you're going to connect to. So this build, I have the OmniNext F7 on here, and as you can see, I have some room in the stack. I wanted to keep these rubber isolators on here to make sure the flight controller was isolated from vibration a little bit. These are like studs, threaded underneath, and has a stud on the top. But as you can see, the height is the height, and there's no changing it. I could stand a little closer. I could use it, but with this build and this board, I don't have grommets that can be attached right to the board, so I had to use these. So with the new flight controller, it has a grommet, so I'm just going to stud these up with a shorter stud and use the grommet. So I'm hoping that I have more room for this VTX in here. This I call this baby Chuck Norris because it is badass. When I ordered these motors from GETFPV, the guy actually commented on them. This is the RS22306. He said that was going to be his second choice. He said these are badass motors, and these were used in a test by one of the better engineers on YouTube, and he got each one of these motors to draw 55 amps each. It's crazy. I tried a high-speed run. I had a big fat tattoo battery on here. It was a 6S. These motors sucked that thing down like it was a piece of junk battery. So maybe one of these days I'm going to find a battery that can keep up with these motors. I just love this guy. It's a lot of fun to fly. It's fast. I have a Foxeer. I forget what model camera's in here, but maybe I'll reveal that as the build goes. So that's it for now. I hope you're enjoying this video so far, and that it's going to help you in your decision about the flight controller. So here's Chuck Norris with the hood up. I try not to put anything on the top so that it's easier to service. And it's probably going to go into focus, but I have a little extra work to find a good beeper, because I decided to take this bad boy and solder it right to my flight controller. So I will not be doing that with the Lux. So I need to find another place for the beeper. This is my Maytech video transmitter. I like this position because I can see the LEDs on here really easily to tell what the frequency is and the power. But hopefully with the LUA scripts, I don't really need that feedback. And there is 30 millimeter spacing on here. So my idea is to put it on the top of the stack, and we'll see how that goes. I just, with this flight with a top mounted battery, I need room for the battery straps. You might be able to see this here, but I like to put a little dab of removable glue, maybe hot glue or some adhesive that can be pulled off for these connectors, so to ensure that they don't come off, especially if they're not really tight fitting. So that's it for now. Stay tuned. Something worth noting, as I was taking this apart, I was reminded that I added a capacitor here. There's that bad boy right there. Why did I add that? Well, early on, SkyZone and firmware updates, I'm not sure whether they actually got it working 100% with the default receiver that came with this, but this is the SkyZone 04X V2. And I've gone through firmware updates and struggling with trying to keep my display from blanking out. It happened a couple times, and after I settled that down, I was having color fluctuations dancing around when I played it back. In hindsight, I think that a lot of it had to do with you're flying and it looks pretty good, but by the time you play it back with a DVR, it doesn't look so good. But while flying, there has been artifacts on the screen, some waviness across the top middle portion. It wasn't exactly right, and it settled down a lot when I put a filter capacitor on the supply voltage to the camera and the video transmitter. The Lumenier Lux has two awesome power supplies. One's 5 volts and one's 9 volts. The 9 volts is switchable, but more importantly, both supplies are filtered. So I noticed that on my first build with this flight controller that the video was much better, and that was the main drive for me to upgrade the flight controller on this one, because I could stand a little more, I could stand some improvement with the video. I like to use this Antec soldering iron for the lighter weight wires and the lighter weight terminals, where there's not too much heat sinking into the board. It melts almost every joint just fine, and I'll substitute for a more robust iron if this one don't do the job. This is 15 watts, and I saw a great tip on YouTube that if you don't have any solder on the tip, then there's not going to be a lot of heat transfer onto the board. So you always have to wet it with a little bit of solder, and that'll make your soldering go much better. So here's another soldering tip. Get a flux pen. Too much coffee, my hands are shaking. If you have plenty of solder and it just isn't flowing, your option is either to add more solder or try to get that solder off and then restart it again, because then you'll have fresh flux. But if you can just dab some flux onto the spot, this is like a clear liquid, but it helps to reflow the solder if there's plenty of solder already on there and the iron and the solder just aren't working well together. So here it is pulled apart, and one of the things that wire kit is going to relieve me of is fighting with these wires. They're regular plastic coated wires, and it's relatively inflexible, hard to get around in the drone. You want to leave a little slack, but it's a pain in the butt. Plus you have to be a soldering genius to solder these little wires on there without the insulation melting back. So with the wire kit, they're going to be silicone, and it's going to be much better. So already I ran into a problem. It's a minor fitment order. I had to order 30mm screws from Mistake Rods, because the problem is this. The grommets are as tall as the threaded portion of these standoffs, so I can't put a standoff on top of this stud and then place this on top, because it won't extend beyond the top. So I would have to put a standoff on top of that. So, and then I would probably still have a dilemma because this is too thick it's going to space further than I really need it. So I'm going to just take that screw and I ordered 30mm length screws. So that should solve my problem on this build. Correction. I said it was very difficult to solder these pads because they're so small. These here, yes, but the majority of the pads and the ones that you'll probably most likely be using actually have holes in them. And my preferred way to solder these is to strip the silicone wire to a very short little nub, use helping hands to hold the wire into the hole, and then solder it like that in place. If you have enough patience, you do it one at a time. I find that it comes out better. If you pre-tin it, the hole's going to get filled up, and then you have to hold the wire, the tin wire, onto the pad and then solder it. You don't even have to pre-tin the wire if you put it in the hole. The trick there, though, is to be very careful. Watch out for teeny, almost invisible strands sticking out that might touch the adjacent pad. So this is my GPS connection. The board is rotated counterclockwise 90 degrees, so it was easier to solder this way. Okay, I did some more work on this. I've rearranged the wires and from the 4-in-1 ESC to the flight controller, and besides the 4 motor wires, I have the red wires battery voltage out, and then I have a current monitor. There's an ADC type connection here. It's not a serial port. Then I have motors. I'll put tape down so that I can power it up without shorts. I'm still waiting for the longer screws. I ordered 25 and 30mm screws to include them in a stack so I can connect everything together, because as I said earlier, the grommet length is the same length as the threaded portion of a stud, so I'm not going to be able to use a stud. They might be called something else, an extender or whatever. So I've soldered the power. I'm getting power from 9 volts on the flight controller here, and ground. Then I connected the other video connections, which would be video out yellow to video in yellow. I have a communication port. This says TX, and I went to TX. It should really be from RX to TX, but I think they labeled this so that you would connect it to TX. I don't know, maybe a little reverse thinking. And then I added a ground wire, even though there's already a ground connection. They're saying the ground wire would probably help the video signal. Then I connected audio, so my audio comes right from the camera, and I'm going direct to the VTX because there's no regular audio connection onto the flight controller. So I'm just going to stick some tape on here to hold it together, plug in the camera, and more importantly the antenna connection. Put an antenna on. I'm going to power it up and see what we have, and if all works well, I'm calling this done until we get to the software. Here's the first battery power up of Chuck Norris. No smoke stopper found in sight. Looks good to me. So GPS is talking. My receiver lit up. My VTX is working. Let me click on my monitor and see if I'm getting anything. I don't know if Betaflight changed the frequency on me or not. Nope. We have video. So I copied and pasted some saved configuration files into here that should be universal. The next thing I'm going to check is that the motors, that the copter arms and the motor spin in the right direction.
0 dB.
I had to set it so that it will arm without a GPS lock. And there they go. And with a little touch, this should be spinning in, and it is. This is spinning in, spinning in, spinning in. Alright, let's give it a little juice. Switch modes.
Flight mode horizon. Flight mode air. Flight mode horizon. Flight mode acro.
Okay, some gyro interaction. And here the mode is trying to compensate for off balance. That's good. Yawing, rolling and yawing, and pitching, all working. Alright, let's see how failsafe works. Ready?
Receiver still connected.
1, 2, 3. It's done. Alright, dropped out of the sky. Oh no, that's it. We'll do configuration next. These are my flight controller settings for the Lumenier Lux H743. Hopefully you can see them. So you can pause the video as needed because I'm going to just roll right through this. I have not flown this yet, so there could be a few missed settings, maybe an incorrect setting here and there. Notice at the top we have gyro, accelerometer, baro, and GPS. I don't have a compass. These settings down here are for my ESC. They may not apply to the ESCs that you're using. Failsafe, I said drop. I increased the delay time a little bit. I don't know, I may not be an expert when it comes to that, but I don't want a little glitch to make this thing drop out of the sky. No presets, didn't use them. Default PID. This is my receiver settings for IRC Ghost. I might enable telemetry, I don't know. I have to see if it's worth it. Here's my modes, the way I use it. 2-switch arming, so I'm using aux 6 to arm it. Might use horizon. Most of the time I fly in acro, but I like to use horizon to land it. And when I flip to horizon, it switches off air mode so it doesn't bounce all over the place. So this is aux 1, so we should see aux 1 later on. GPS rescue. I might try it. I don't know, I haven't used it. Got the beeper on a switch. So here's aux 1. If it's low, I got air mode. If it's high, I get air mode. If it's in horizon, I don't. This is, well, you flip over after crash. I thought that this is what was coming up. This is how you turn off your VTX. You might already know that. If you connect the VTX to 9 volts, power it by 9 volts from the board, which I thought is an excellent idea. This is how you set it up on a switch to turn it off. So if I take my second switch on my transmitter, flip it, that's on aux2. If I flip it to the midpoint, that video, the voltage to the video transmitter goes away. I use launch control on this. It's a lot of fun. I recommend you try it. There's an adjustment. This one is so that I can switch on-screen display profiles. I have one with all the goodies on there, GPS. If I lose it, I'll have GPS recorded, but if I'm following someone's airplane, then I might want to switch off the extra information from the screen that I don't need. So it's a cleaner display. Servos, nada, GPS. If this was in a better position, I actually was starting to pick up 2 satellites indoors. Here's the motors. I'm using D-Shot 600. I don't have an ESC sensor. I only have current output on mine. I might lower that a little bit. It's my on-screen display. And then if I look at profile 2, the GPS stats go away. I might take more away. I don't know. Now it's back. I'll roll this down so you can have a look. This is set up for my VTX. Let's have a look at the sensors here. So this barometer on this board behaves much better than my other 2 Airbot Omnis. They used an interesting barometer on there that I don't think Betaflight properly supported, if they supported it at all. This is a DPS 310. It seems to be very responsive. I'm guessing the air in the house is fluctuating because the heater is running and that's drawing air from the house. And wind outside might be affecting it too. And maybe the hot air from my breath is affecting it. But everything else looks pretty stable. You can increase the sensitivity of the readings here, but I'm not going to have to get into all of that. It's going to be just fine. And that's really all that I have to show you. If you use this board, good luck. I like it. I love the features in it. And I flew it with a 7-inch quad, and it flies well. So I bought another one.